Let's talk a little bit about positive and negative numbers. Now, traditionally, you've worked with something called positive numbers, or zero, so numbers that are greater than zero. So numbers that are greater than zero include but are not limited to 1, 2, 3, 4, 5, and 6, etc., etc. Basically numbers that move in the direction to the right. Now, negative numbers move in the opposite direction. So whereas positive numbers move this way, negative numbers are going to move to the left. They'll be less than zero. So here are some examples of negative numbers. Negative numbers are -1, -2, -3, on and on and on and on into infinity, but this time in the left direction. Now, opposite numbers are numbers that are the same distance from zero, but in the opposite direction. So let me give you an example. The opposite of 6 would be -6, or the opposite of -3 would be +3. These are called opposite numbers. Now, integers are all the numbers that we've been talking about. They exist, they're all whole numbers and they're opposites, and this also includes 0. So, for instance, opposites we talked about earlier, the opposite of 7 is -7. The opposite of -7 is 7. Now, negative numbers are used in many ways in real life that you've probably already seen. So if you ever experience really, really cold weather, so weather that's typically not in Atlanta, Georgia, but weather that's really cold, they would exist below 0, right? This is degrees Celsius, note. So 0 is at freezing, and then everything else is below. Now, you also might experience negative numbers with sea level. So if something goes below sea level, something sinks below sea level, that means they're going in the negative direction, this time vertically rather than to the left. Also, debt is a good example of negative numbers. So if you borrow $5,000 from the bank, that means you'll end up owing them $5,000. This period should be a comma. You'll end up owing them $5,000. That is represented by a negative $5,000. So basically, over the next couple of days, we'll be developing some rules that are similar to driving rules when working with integers. So rules that you can live by in order to compute with these negative numbers, because they are a little bit more complicated than just positive number work. One thing I want you to keep in mind is that if there isn't a number, if there isn't a negative sign in front of a number, then that number is positive. So for example, the number 9 is actually a positive 9. The only time that it'll be negative is if a negative sign is in front of it. Now let's talk a little bit about absolute value. This is something that you'll need to know. Absolute value is a number's distance from 0. Now that distance is positive, okay? So two numbers that are the same distance from 0 are said to be opposites, meaning they have the same absolute value. So the absolute value of the number 5 is 5, which is exactly the same as the absolute value of -5. Those two have equal absolute values, even though they are in opposite directions from 0. So they have equal absolute values, but are in opposite directions from 0. But let's talk a little bit about what absolute value is. So absolute value is, again, a number's distance from 0. Now that distance is always going to be positive. And here's the symbol that you'll use. You see this X and these two straight lines around the X? This means find the absolute value of whatever value is within these two lines. So it's used for absolute value. This means find the absolute value of X. Now the absolute value of -3 is something, the absolute value of +5 is something, and the absolute value of 0 is something. I want you to pause the video and try it. Try to find the absolute values of these different things. Okay, by now you've probably written it down. The absolute value of -3 is +3. The absolute value of +5 is +5. And the absolute value of 0 is just 0. Remember, that absolute value is the number's positive distance from 0. All right, that's it.